welcome to another episode of Physics with Noshir Alam. And now we are going to discuss in this episode Kirchhoffs laws. And when you discuss Kirchhoffs laws, the first law, number one, the first law, literally the name is first law, or Kirchhoffs current law. Please remember the name, because in the exam you can be asked which is the first law. Is it the current law or is it another law? So remember that the first law is Kirchhoffs current law. Now, although the name is very daunting, I don't blame the name, but believe me, you've done this in O levels. And what is the concept? The concept is, let's say this is a point, okay? And you have a cell over here. And we connect this point with a resistor over here and a resistor over here. And you connect it like this. Now, if I say that the current entering this point is 2 amperes, all right? And the current which goes down is 0.5 ampere. My question to you would be, what is the current going this way? Your answer would be, what's the difficulty in that? It's 1.5 ampere. So yakeen kare, this is Kirchhoffs current law. Isn't that easy? Kirchhoffs current law ki statement likhne ko aati hai, and that statement is that the algebraic sum of all the currents entering a node is always 0. Now, what do we mean by that? This dot that I was referring to is called a node. Node एक ऐसा point होता है जहाँ पे current split होता है. This is also a node. Current is coming in, currents are coming in, another current is going out. The point where the current splits or they combine, that's a node. So algebraic sum of all the currents entering a node is always 0. Asan alfaz mein, in easier words, what they're trying to say over here is that the current entering must be equal to what? The current that is leaving the node. So current entering the node must be equal to current leaving the node. So in this example, 2 ampere entered, 1.5 and 0.5 ampere exited. If you add these two, these are the currents leaving and the current entering, they will always be equal. Remember, when they ask you to define it, this is the definition, that the algebraic sum of all the currents entering a node is 0. Uski implication, the implication of that is this, and this is the example that you have. Now, please remember that the first law is based on the law of conservation of charge. Law of conservation of charge ke upar ye based hai. Do not forget that. You can be asked on which law is it based. You can even get a question like this, in which they say that this is a node and you have a current coming in from here, I1. You have a current going out, I2. You have another current coming in, I3. Let's say you have another current coming from here, I4. And they'll say apply KCL or the first law. Again, current entering must be equal to current leaving. So you can say that I3, I1 and I4 are entering and I2 is leaving. So I1 plus I4 plus I3, current entering, is equals to I2, current leaving. That is the answer. So that's all with Kirchhoffs current law. Now, let's talk of the second law. The second law, or Kirchhoffs voltage law. Second law भी कहते हैं और Kirchhoffs का voltage law भी कहते हैं. Again, let me remind you that you've done it. How have you done it? Let's say you have a battery of 10 volts. You have a voltage, a resistance over here, you have a resistance over here, and you have a resistance over here. Now, if I say that out of 10 volts, 1 volt dropped across this resistor, 3 volts dropped across this resistor, what is the voltage drop across this one? what will your answer be? You will say 10 volts आपने सप्लाई किया था, 1 volt इधर गिरा, 3 volts इधर गिरा, तो बच गया कितना? What is 3 plus 1? 4. What is 10 minus 4? 6. So 6 volts is the voltage over here. Have you not done this before? Of course you have. And this is called Kirchhoffs voltage law. The way they define it, of course, is very different. Please don't forget Kirchhoffs voltage law is also the second law. They can ask you what the second law is. The definition, the way they define it is that the algebraic sum of EMFs in a closed loop must be equal to the sum of potential differences. Please write down the full word, potential differences, in that loop. So the algebraic sum of EMFs in a closed loop it must be equal to the sum of potential differences in that loop. Now, when you read that statement, the first thing that should come to your head is, oh my god, that statement is so confusing. मैं आपको आसान करके बता रहा हूँ कि भाई ये जो 10 वोल्ट की बैटरी लगी हुई है, this is the EMF in a closed loop. Closed loop मतलब होता है closed circuit. And this EMF must be equal to the sum of potential differences in that loop. It's actually that simple. Honestly, इतना आसान है कि 1 और 3 और 6 को ऐड करें तो 10 बन जाएगा. अब अगर मैं आपसे पूछूं on which law this is based, then your answer should be this is based on the law of conservation of energy. It's actually that simple. It's based on the law of conservation of energy. I mean, the concept is that simple. Of course, the questions can be tricky, but literally this is the concept. So to give you an idea of how to handle some tricky questions, let's go with an example. Example, I think you have a cell and you have two resistances over here like this, and you have one resistance over here, and this is your circuit pretty much. Let's say the cell's EMF is E. Let's say this is I1, this is R1. Let's call this as I2, this is R2, this is I3, R3, R1, and let's label the edges A, B, C, D, E, F, G, H. H is मेरे ज़हन में आई है, and I was wanting to share it with you. I don't know why I didn't do it earlier. To gain maximum benefits out of my lectures online, and you should, please write down everything. A lot of students, some of my students, make this mistake. This is a virtual classroom, so I don't know. I'm very sure that I'm not teaching everybody. But I want to share something with you that whenever I'm teaching a lesson, the only one thing I tell my students is to write down everything. देखो, जब आपने हाथ से लिखोगे ना एक चीज़, then you will realize कि आप गलती कहाँ करते हो. If you just keep on listening to my voice and you just keep on following the lecture like it's going and you're just watching it with your hands folded, believe me, you're not learning. If I give you a question right after, there's a 99% chance you'll go wrong. But if you're writing it with your hand, you will definitely get stuck. And that's where you will pause the video, go back and play it again and again and again until you get it. So the point of this medium, the point why I started these videos, why I came up with this channel, and my co-founders are also on the same wavelength as me, कि if you need to watch my video 1,000 times, you should be able to. Without any excuse, without any argument. This is the reason why we could not watch. No, there's no reason. You should be able to watch it. And watch it at your pace. Don't fast forward it. Don't sleep through it. Wake up and watch it, because you are the one eventually who's going to get the benefit out of it, right? So please do justice to all the effort that has been that is being put in, and write down everything and try to solve. जब मैं कहता हूँ solve करो खुद, तो वाकई में वीडियो को pause करके खुद solve करने की कोशिश किया करो. It will come to your benefit. All right. Great. Well, that was the teacher in me for some time. All right, let's get back. So this is the question that they've given you, and now what they're telling you to do is they're saying that the first thing you do is apply KCL to find an equation relating I1, I2, I3. Okay. Now that is a very simple question. Because if they ask you that question, the first thing you'll do is you'll try to find a node. So this is a node and this is a node. This is not a node. मैंने क्या बताया था? ऐसा point जहाँ पे current split हो या add हो. So this is a node and this is a node. I'll use a different color and let's highlight that point. So this is a node and this is a node. You can focus on any. Let's focus on this one. Now, what is the current entering this node? Current I1 is entering the node. What is the current leaving? I2 and I3 are leaving. So what's the equation then? Very simple. I1 is equals to I2 plus I3. I2 and I3 add up and they form I1. If you apply the same equation over here and I ask you apply KCL and get me the equation, you'll say I2 and I3 are adding. So I2 plus I3 is equals to I1. Same equation. The second question will be apply KVL, apply Kirchhoffs voltage law to part A, loop A, B, C, D, E, H, A. As an example, let's take this example. So remember, whenever they will ask you to apply KVL, they will always give you a loop. The loop would tell you in what direction you're supposed to go. So the loop is very clear. You're supposed to go upper or yahan pe. So the loop is very clear. Also, one more thing, that the first and the last letter of the loop must always be the same. That shows that the loop is closed. Like I said in the definition, it's a closed loop. Closed loop नहीं होगा तो current flow नहीं करेगा, जाहिर है. So it's a closed loop, and remember to follow the letters very carefully, because when you reach here, a lot of kids can make this mistake, then go down, but you have to go up because the loop is telling you to go up. Okay, so follow the loop. अब loop के direction को अपने ज़हन में रखो और then apply KVL. Apply KVL. KVL is not difficult. Understanding that what loop you're in is the tricky part. Now, the first question to you is, in this loop, A, B, C, D, E, H, A, in this loop, did you have any source? The answer is yes. This is the source in this loop. Question is, how many sources do you have? I just have one source. Second question to you, is the source in the direction of the loop or is it against it? The answer is it's in the direction. क्योंकि बैटरी का जो करंट है वो भी इस तरफ निकल रहा है और लूप भी हमारा इसी तरह चल रहा है. फॉलो द लेटर्स H A B C, H A B C D E H A B. So it's following. So remember that if the battery is in the direction of the loop, तो उसका EMF वैसे का वैसे लिखा जाएगा. If the battery was against the loop, which means that the loop was going from H to A, लेकिन बैटरी आपने उल्टी लगाई, बैटरी का पॉजिटिव टर्म लेते होता है, नेगेटिव टर्म लेते हो, आप माइनस ही लिखते हैं इसको. सही है. So the point that I'm making over here is, please note this down, that the EMF and the current must be in the direction of the loop. If not, then put a negative sign with them. अगर ना हो तो negative sign डाल दें. ठीक है. So अभी तो है. अभी तो it's in the direction, so there's no need of the negative sign. At least the EMF is. Now, EMFs का sum must be equal to the sum of potential differences in that loop. So let's start from A to B. Is there any potential drop? No. पोटेंशियल ड्रॉप का मतलब है वोल्टेज ड्रॉप का मतलब V is equal to IR. रेजिस्टेंस ही नहीं है तो वोल्टेज कहाँ ड्रॉप होगा. ए से भी तो कुछ नहीं है. लेट्स गो टू बी टू सी में येस ऑफ कोर्स देयर इज अ वोल्टेज ड्रॉप. देयर इज R1 एंड देन देयर इज I1. सो यूल डू I1 into R1 बिकॉज I1 जब इसमें से गुजरेगा तो यहाँ पे एक वोल्टेज ड्रॉप होगा. सो E is equals to I1 into R1. नाउ plus I1 or minus I1? The answer is plus I1 because loop is going A, B, C, D. And if the loop is going A, B, C, D, my current is also going from A to B to C. So they are following each other. The loop is going from A to B to C. The current is also going from A to B to C. All right. So I1, R1. Moving on. So from C to D, do you see any resistance? No. So no voltage drop. D to E. यहाँ पे देखो D to E है तो मैं भी D to E, D से E जा रहा हूँ. फिर E से H. So E से H जाएं. Yes, I see a resistance. There's a current. So I2 into R2. So I2 into R2 plus I2 into R2. The reason why I said plus is because the current is in the direction. And then from, if you see H to A, so H to A over there and over here, no resistance. आप कहेंगे बैटरी आ गई तो बैटरी तो हम ऑलरेडी यहाँ पे डाल चुके हैं. सो ए से में रेजिस्टेंस कोई नहीं है. सो दिस इज योर फाइनल आंसर. आई होप इट मेक्स सेंस. Let's try another example with the same circuit. So with the same circuit, another example would be to, in fact, you should pause the video and you try this loop. You should try for loop H, G, F, E, H. Interesting. H, G, F, E, H. So you know that this loop is over here. H, G, F, E, H. Try to kare. Let's see if you get the right answer or not. Pause the video and try it. Remember, you're applying Kirchhoffs voltage law. So, pehle sum of EMFs aayega equal to sum of potential differences in that loop. Try it. All right. I hope you tried getting the answer. So, the correct answer is, pehli baat to ye, in this particular loop, H, G, F, E, H, there is no source, so you will write 0 is equals to. Now move with the letters. H से G कोई रेजिस्टेंस नहीं थी, so कोई वोल्टेज ड्रॉप नहीं हुआ. G से F क्या हुआ? G से F में of course रेजिस्टेंस भी है और करंट भी है, but the current is going from F to G, but the loop letters are going from G to F. So what do? You reverse the direction of current. So that means I want you to put minus I3 into R3. Does that make sense? Because look, the loop is going from G to F, but the current is going from F to G. So you have to reverse the direction of current. So minus I3 R3, then F to E, nothing. And what about E to H? The current is in the direction. E to H, the current is in the direction. So plus I2 R2. That is the answer to this question. So isi tarah they can give you any loop and you should be able to fill up the equations properly. Very simple questions, very easy to do. The only problem is people get confused in the loops. I hope it's clear to you. I wish you best of luck. Great.